Hello, and thank you for joining us for the Supplier Recovery Redefined, the power of visual data integration or saving time and money with digital dashboards. Your presenters today will be Aaron Armstrong, myself. Olivia Bernis was not able to be here, but was an interpretation. Today we will be talking about aerospace manufacturing fundamentals and supplier performance and recovery fundamentals. The problem we've identified, as well as the improvement opportunity that we're putting forward, the costs and benefits of that opportunity, the approach and timeline, as well as key obstacles and enablers. We'll also cover briefly at the end sustainability of the project. Aerospace manufacturing is driven by a long-term production schedule that relies on parts and assemblies that are assembled into the final product being delivered on time and in perfect condition. When we manage the aerospace manufacturing supply chain, we have to consider how parts are going to make it to our production line, from the sourcing and acquisition of raw materials by suppliers deep in the supply chain to the end item producer who delivers directly to the Boeing production line for installation on the plane. Raw materials include elements such as fabric, forms of metal, paints, adhesives, standards, and so much more. After raw material comes machining, which involves people, which is staffing and machines. Once parts are successfully machined, they regularly go through various outside processes such as heat treatment, painting, anodize, and more, which is usually done at an authorized sub-tier supplier. Often the parts are further handled to create assemblies from those individual parts, and all of this has to be carefully timed and relatively predictable in order to support a production schedule that was put in place sometimes years earlier. Suppliers receive purchase orders from Boeing that say we want to buy something that they said they can build perfectly and on time. The ultimate goal of the supply chain at Boeing is therefore perfect parts on time, every time. Thanks to issues with the supply chain fundamentals mentioned in the previous slide, we don't always get perfect parts on time. Perhaps war causes the supplier's material to arrive late, or a plane crashes into one of their finished processors, or a pandemic hits and they can't find people to use the machines, or a door falls off a plane and throws demand into chaos. And then parts start arriving late, and a backlog of delinquent orders is created. Now, if one of these things happens, often the supplier can recover with a little elbow grease and overtime. Who doesn't like overtime? But if several of these things happen at the same time, or close to the same time, the backlog can continue to grow because the pile of delinquent orders is greater than the time and other resources available to address it. We have people who can help. They are called industrial engineers, or IEs. IEs are very good at collecting information about all of the resources needed to finish the delinquent work of the problem, and information about all of the available resources that can be applied to the problem. The IEs help the suppliers to create a plan for how the resources can be best used to burn down that pile of delinquencies, like a pile of leaves, while creating perfect parts and protecting Boeing production schedules, which is where the on-time part comes in. And this process of eliminating delinquencies is called supplier recovery. The other primary stakeholders directly affected by supplier recoveries include the suppliers involved in Boeing commercial airplane programs, supply chain managers at Boeing, and Boeing's leadership. IEs face unsustainable workloads and inefficiencies, suppliers experience delayed recovery efforts, and leadership is burdened with higher operational costs. The current process for managing supplier recovery at Boeing is highly manual, leading to multiple inefficiencies, input errors, and increased labor costs. Industrial engineers, IEs, those responsible for assessing suppliers' production readiness, supporting supplier recovery efforts, and training suppliers on industrial engineering principles, spend up to an hour and a half per day on updates and error correction, and up to 8 hours per recovery on plan restrikes. This manual approach involves extensive tracking and updating of recovery and delinquency burn down plans using Excel, most of which could be automated, contributing to non-value added costs. Each IE at Boeing manages 30 or more suppliers involved in Boeing commercial airplane programs, ensuring that suppliers can manufacture on time. IE tasks include receiving and integrating daily quality and delivery scores, detailed reports on past due purchase orders, shortage reports, and comparing projected loads versus master schedule load dates. Currently, the process for managing supplier recovery requires IEs to spend on average 45 minutes for daily updates and communication, and 30 minutes to an hour for restrikes, which are required 4 to 8 times per recovery per year, among other miscellaneous analysis, reporting, manual error correction, and support tasks, leading to an estimated annual labor cost of between $9,000 and $26,000 per recovery per year. With around 200 supplier recoveries managed by Boeing each year, this results in an average of 2.6 million in non-value added costs. Addressing this problem is crucial for improving the efficiency of supplier recovery processes, reducing labor costs, and enhancing overall supply chain performance. Streamlining these processes can lead to more effective supplier management, quicker recovery times, and significant cost savings for Boeing. The current system we have just described is prone to human errors and does not encourage or enable effective real-time communication across teams. We have a solution, a digital dashboard tool based on Tableau data visualization technology. With Tableau, we can automate and streamline much of the supplier recovery process. This means our engineers will spend less time on manual updates and more time on valuable work like drilling down into root cause and working cross-functionally to figure out the best corrective actions. The digital dashboard will provide real-time updates and customizable views, making it easier for everyone involved to see the status of supplier recovery efforts instantly. This shared visibility will improve coordination and communication, not just within our team, but also with our suppliers. By implementing this digital solution, we expect to save on average $2.6 million annually by reducing non-value added manual workload. Automation will also improve data accuracy, reducing human errors and the need for repeated adjustments. Stakeholders will be able to access updates from anywhere and customize their views to instantly highlight issues that need the most attention. In short, our new approach will make the entire process faster, cheaper, and more reliable. We plan to start by mapping out our current processes and gathering data on how things work now. We'll then develop the new system in collaboration with our tech team, test it with one of our suppliers, and refine it based on feedback before rolling it out more broadly. This digital dashboard will revolutionize our supplier recovery process, saving money, reducing errors, and improving communication, ultimately making Boeing's supply chain more efficient and effective, and making our IEs happier and more productive.
The costs of implementing this solution include Tableau licenses, estimated $10,000 annually. The development and integration of the Tableau dashboard with the help of the tech integration team will cost approximately $19,000. And training and change management to ensure effective use of the new system will add another $25,000. The total initial investment for the project is around $54,000. To calculate the return on investment (ROI), we compare the net benefits over a specified period to the total costs. In the first year, after subtracting the initial investment from the annual savings, we expect to save at least $1.8 million on minimum hours required currently dedicated to non-value added activities, with average forecasted annual efficiency returns of $2.7 million stabilized over 10 years. Analyzing for net present value, we are rewarded with the total realized efficiency value gains of $11 million. A dashboard implementation provides substantial cost savings and efficiency gains that far outweigh the initial and ongoing costs. By automating this portion of the supplier recovery process, Boeing can enhance accuracy, improve decision making, and achieve significant labor cost savings, leading to a more resilient and efficient supply chain. This investment guarantees a high return and supports Boeing's commitment to operational excellence, growing production rates, and maintaining a competitive edge in the aerospace industry. Our approach to improving the supply recovery process involves several key steps to ensure measurability and timeliness. We have already mapped out the current state of the value stream for the four major IE processes: initiating burndown, daily burndown management, burndown restrike, and burndown communication. This allowed us to identify baseline cycle times, areas of waste, communication flow, and improvement opportunities. Next, we collected baseline data for the identified metrics such as IE labor hours and cost per supply recovery, percentage of purchase order line discrepancies, and supply chain operation satisfaction scores. This data collection took place over 3 weeks and let us establish an accurate current state. We then distributed a customer satisfaction survey to the supply chain operations team to gather feedback on the current process and identify desired functionalities for the new system. The survey took 1 week, with another week to identify and record additional functionalities, or Kaizen bursts. Next, gaps in the current state system will be assessed and future state functionalities and requirements will be identified. We will then draft future state value stream maps and mock-up Tableau views for the burndown dashboard. Mapping data sources for the Tableau dashboard and meeting with the tech integration team to share design and requirements will take 2 days each. The tech integration team will develop the dashboard over 2 months. During this period, a small number of suppliers will be selected to test the dashboard, and a cross-functional team will assess its efficiency and accuracy over 1.5 months. Any necessary changes will be implemented, followed by the launch of the live dashboard, which will take approximately 2 weeks. Post-launch, future state value stream maps will be updated with new cycle times. A final customer satisfaction survey will be sent out over 2 weeks to gather feedback and measure improvements. And additionally, industrial engineering tip sheets will be created to ensure the process is maintained, taking 3 days, and a revised communication process will be implemented over the course of 1 week. The success of this project hinges on overcoming several key obstacles and leveraging specific enablers. One significant obstacle is resistance to change, as team members and stakeholders may be reluctant to move away from the familiar manual system, either because it is comfortable or because it hides inactivity and disengagement very well. Additionally, integrating existing data systems with the Tableau could present technical challenges, especially if data quality or consistency issues arise. Training and ensuring the adoption of the new system might also require more time and resources than initially anticipated. Resource allocation could be another hurdle, as both the tech integration team and IE team may have other competing priorities that delay the project timeline. The upfront costs for Tableau licenses and development could be seen as substantial, particularly in the current budget environment. Collecting accurate baseline data is crucial for measuring success, but this process can be challenging and time-consuming. Transitioning from the old system to the new one may necessitate downtime, potentially disrupting ongoing operations. Moreover, ensuring continuous support and maintenance after implementation will be essential for long-term sustained success. Achieving alignment and support from all key stakeholders throughout the project lifecycle can also be challenging. Lastly, unforeseen technical issues might arise during development and integration, potentially causing delays and increasing costs. On the other hand, strong leadership support will be a crucial enabler for this project, securing the necessary resources and driving organizational buy-in. Clear and regular communication with all stakeholders will help manage expectations and foster support. Comprehensive training programs will ensure all users are proficient and comfortable with the new system. Close collaboration between the industrial engineering team, tech integration team, and supply chain operations will ensure all requirements are met and issues promptly addressed. Ensuring robust data management across all systems will facilitate smooth integration and reliable outputs from Tableau. The system integration and potential technical issues are already greatly mitigated by the maturity of the Tableau dashboard technology within the Boeing ecosystem. Implementing the new system in phases can help further manage risks and minimize operational disruptions. Establishing feedback mechanisms will allow for early identification and resolution of issues, ensuring the system meets user needs. Pilot testing using live data from select suppliers will provide real-time world testing and refinement before full-scale implementation. Strong project management practices will keep the project on track within budget and aligned to milestones. Finally, providing ongoing support and regular updates post-implementation will ensure the system remains effective and up to date, addressing any issues that arise. By addressing these obstacles and leveraging the enablers, the project has a solid foundation for success, leading to a more efficient and reliable supply recovery process at Boeing.
This dashboard solution and process improvements are designed to be sustainable. By automating repetitive tasks, we not only reduce labor costs, but also increase accuracy and efficiency, providing long-term benefits. Regular training and support ensure that team members remain proficient with the system. Ongoing stakeholder engagement and feedback mechanisms will help the system evolve with changing needs. Additionally, the phased implementation approach and the provision for regular updates and maintenance will help the system remain relevant and effective. This comprehensive approach ensures that the improvements are not only achievable now, but also sustainable in the long term, leading to a more efficient and reliable supplier recovery process at Boeing. Thank you so much for your attention. We will now open the presentation to questions.